Hey y'all, Country Coder here. Sorry for the delay, but here's a banger of a project. I'll walk you through the components of my Dark Souls 3 Armor Calculator. It is a tool designed to optimize your armor setup in Dark Souls 3 by balancing damage reduction and equipment load. In Dark Souls 3, your equipment load directly affects your roll speed. Going over 30% equip load takes you from a fast roll to a medium roll. Going over 70% brings you from a medium roll to a fat roll. That's an unusable roll. I developed this tool to calculate the best armor combinations based on a boss's damage profile while staying under the 30% and 70% thresholds. The end result is two armor sets, one for each threshold, that give the highest combined damage reduction against a selected boss. Let's look at the core components that make this project work. Our data management layer is built with Spring Boot and JPA. This application imports data using a data loader that reads the JSON files for armor, weapon, rings, and shields. This loader uses Jackson to deserialize JSON into Java objects, then saves these items into the database via Spring Data repositories. This approach ensures that our item database is populated correctly using proper naming strategies to handle JSON keys, whether they're in snake case or lower camel case. We have the repository layer. I have several repository interfaces tailored for each entity. We have the item repository, gauntlet repository, helm repository, leggings repository, and chest repository. These interfaces provide methods to retrieve items based on the type of armor slot, allowing precise filtering for gauntlets, helms, chests, and leggings. We have the build repository and build item repository. These repositories manage our builds and the relationships between builds and items. The build item repository even includes custom JPQL queries for deleting and fetching build items by their composite keys. Player repository. This interface supports player-related operations, including looking up a player by name, which is essential for saving builds with user context. The backend includes a brute force algorithm to evaluate every possible armor combination, chest, gauntlets, helmets, and leggings, and calculates a reduction score based on a boss's damage profile. This score considers both the effectiveness of damage reduction and the total weight, ensuring that the build stays within a specified percentage of the maximum equip load. The service layer abstracts this complexity, providing two methods. One for fast roll builds, keeping a load under 30%, and one for medium roll builds, up to 70%. This encapsulation allows other parts of the application, like the REST controllers or even the GUI, to easily call for optimization without having to worry about the actual logic. To interact with the system, I built a set of REST controllers that expose CRUD operations for builds, players, and build items. These controllers follow REST best practices, providing endpoints to create, retrieve, update, and delete builds and player information, ensuring a backend that is robust and maintainable. We have several auxiliary services. This includes retrieve gauntlets, retrieve helms, and retrieve leggings to ensure our optimization algorithm receives the correct subset of data. Each one of these services is built using Spring's dependency injection. My focus was on the back end, but I also built a simple abstract window toolkit based GUI to be able to show the system in action. The graphical user interface guides the user through inputting their equipment load, selecting items, and viewing the optimized builds. The real magic happens behind the scenes in the back end. After running the optimization process, I achieved an armor set on my in-game character that hits exactly 29.9%.